welcome to Tech to Tech presented by KYZEN, where we will explore common cleaning questions and answers. Let's get started. I would like to introduce KYZEN's own Wayne Raney.
Thanks, William. So during this presentation, we'll be talking about concentration measurement and control methods for your wash tank. Most of KYZEN clients are either electronic in nature and have the need to clean soldering fluxes from printed circuit boards, or they're more industrial in nature where they need to clean oils and coolants from metal parts in a factory. These two different industries use KYZEN chemistry, and we'll be talking about measurement and control methods to maintain the proper concentration of cleaning chemistry in your wash tank. This is the basic outline of today's presentation. We'll be talking about devices that we offer to measure the concentration, and then ways that we offer to control or change the concentration. Last thing we're going to be talking about are the combination systems that do both measure and control the concentration in your wash tank. So as we progress down this list, for the methods of control and measurement, it goes from basic, labor-intensive, and operator-dependent devices or methods. Then towards the bottom, or on to number 3, we go to more complex, automatic, and operator-independent devices that KYZEN offers. These are most of the ways to maintain proper concentration in either the electronics or parts washer or the industrial parts washer. First, we're going to be talking about the measurement devices. The first one we're going to be talking about is the refractive index method. So you'll need a refractometer. This is an example of a refractometer that measures the amount in degrees Brix that the light bends or changes in direction as you look through the eyepiece of the device. Once you get that number, then we'll compare it to a control chart for that particular type of chemistry. The next manual method to measure concentration is by way of titration. The titration test kit is offered by KYZEN. It contains some of the items in this picture, and you'll be able to determine the concentration by adding a titrant to a solute until you see a color change or an endpoint. We offer 3 types of kits: the alkaline, acidic, and neutral titration test kits. This is an example of a procedure of an alkaline titration test kit. It's as simple as measuring out certain volumes, adding indicator, and then adding the titrant until the color changes. You'll count the number of drops of titrant and then relate that to a concentration percentage in a chart like this one. The next way of measurement is by way of conductivity. Basically, conductivity is the measurement of a material's ability to conduct electricity in a solution. It's measured using a conductivity meter and is measured in units of Siemens. We offer this in a test kit. And this test kit includes several standards and a calibration procedure so that you can quickly measure the conductivity of your solution. Again, you'll compare this to a number in the control chart to get the measured concentration percentage. The y-axis is your indicated value in Siemens. The x-axis shows the corresponding percentage of KYZEN wash chemistry concentration in your wash bath. So in general, these first 3 measurement methods are used in the industrial field in applications. This last method, the Type 2 test kit, is only used in the electronics field to measure aqueous electronics cleaning chemistry or agents. This test kit, which contains a stopper, flask, beaker, and reagent, also comes with a control chart for your particular type of chemistry. To put it in simple terms, you'll draw a sample, allow it to phase separate in this flask, and then you'll see a solvent layer, which will be pink in color. This amount of solvent layer or split will be converted to a concentration percentage using the control chart for the chemistry. The next thing we're going to be jumping to are the control methods. When I say control, we're talking about ways to change the concentration, but without the ability to measure the concentration. The different types of control methods are manual and semi-automatic. The semi-automatic way is by way of a Chemtroller. First is the manual method. Here, one of our managers, Ethan, is showcasing a manual method of adding chemistry. It's very labor intensive. You have to ensure the quantity is correct to get to your target concentration. Luckily, this type of chemistry that he's adding is pre-diluted. But if it's not pre-diluted, then you'll have to manually check the value of the concentration. And so you'll have to use one of these measurement devices that we already talked about. If you didn't reach your target, then you'll have to manually add again and then recheck your target concentration to see if you got there. The next control method is the KYZEN Chemtroller. It's basically a proportional pump that's run off of water pressure. When your wash tank lowers to a level that it calls for water on your autofill, then that water is directed to this proportioner. The water pressure will then activate a piston in the Chemtroller and draw up chemistry and mix with the water to a preset value on your control knob. Again, it'll measure out the proper amount, a proportion of chemistry to water, but you'll have to manually use one of these measurement methods to see how the concentration changed, and then adjust the set point on the Chemtroller separately according to your set point concentration. Again, you'll manually have to use one of these measurement methods to see how the concentration changed, and then adjust your set point accordingly. Here's an example of how two Chemtrollers were installed to control the wash tank and the rinse tank concentration separately. The Chemtroller is an addition device that can be used in both electronics and the industrial applications. Again, this method is more operator independent than manual additions, but is still more operator dependent than these last three. For systems that both measure and control concentration within one system, we offer the CCS, the Analyst, and the PCS. First, we're going to be talking about the CCS, or the Conductivity Control System. This system is mainly used in industrial applications. If your wash concentration is successfully controlled by way of conductivity, then the CCS is going to work for your process. As described in the illustration here, the wash pump provides steady flow past the conductivity probe and sends that 4 to 20 milliamp signal to a metering pump. If the concentration is low, then a metering pump will add chemistry until it reaches close to the set point value. Here's a typical install where the metering pump and meter are mounted above the chemistry drum. Flow past the probe representing the conductivity, measured in Siemens, is displayed on the conductivity meter. This is converted to a percentage of concentration, again on another control chart. This is another typical install. It's fairly simple, and it's a simple system. The Analyst is next in line. It's a more independent and complex system than the Chemtroller or the CCS, but it's more dependent than the PCS, which we'll talk about later. The Analyst is mainly used in electronics applications whose wash bath flux loading doesn't affect the readout of the sensor. These are the main components of the Analyst. You got the HMI, the sensor, the power supply, and the control box. This HMI is fairly simple and mounted and installed on existing washers. Here the HMI is illustrated in the top left as our original Analyst, but the Analyst 2, which is our latest version, is in the lower right. The Analyst uses a proprietary sonic velocity probe which measures changes in the totality of the fluid passing through the prongs. And this is an example of the first screen on the HMI. It has a lot more functionality than the conductivity control system, but a little less functionality than the process control system. You have a whole array of analytics that you can send to and monitor from your desk, so you don't have to sit out there on the shop floor doing it. So far, the Analyst is used to measure the concentration, but it has the ability to control a chemistry dosing pump by a trigger within the software. So far, we talked about measurement and control. Now, the last method for both is the PCS. This is the most operator-independent system to measure and control concentration. The PCS is the most hands-off system we offer. It is mainly used in the electronic circuit board cleaning sector. You can monitor most of the process parameters remotely. It uses the same sonic velocity probe as the KYZEN Analyst. This is a typical install which measures the representative wash solution of what's spraying on your parts in the washer. That's important when you're talking about your wash process. This installation has the PCS sitting next to the inline washer, though the engineer can remotely monitor from his desk, as we said a couple times before. The HMI is illustrated here, and the operator engineer can click on different icons to display different values. Here are the icons that they can click on to access different menus. For example, the drum icon can display such things as gallons per hour, gallons used. If you click on the PCS icon, you can see stuff like the set point value and other icons such as wash pump run hours and troubleshooting data. You have even more options if you click on the KYZEN K in the upper left of the screen. Here, there's several more options. So the calibration page is pictured on the left, and then an example of the data analytics is also in the illustration to the right. And recording of all this data is available with KYZEN Analytics. So in conclusion or summary, there are several methods to measurement and control of your wash bath chemistry concentration percentage. There's also ways to combine the two to get more functionality, such as in the CCS, the Analyst, and the PCS. Also, some of these are more useful in electronic applications, and others are more suited for industrial applications. There are different questions that people have when talking about this. And so some of the frequently asked question is, can I integrate my own proportioning pump with the KYZEN Analyst? The short answer is yes. If your pump can receive a 0 to 10 volt DC or 4 to 20 milliamp signal, then it can make additions. Next one is, can I use the KYZEN Analyst and or PCS with my washer in an industrial application that cleans off oils and coolants from my metal parts? Again, the short answer is yes, though we must do a lot of homework by collecting samples of your oils and coolants to make sure that they don't affect the true concentration reading. Another one is, can I use the KYZEN CCS for electronics applications where I'm cleaning flux from circuit boards in an aqueous washer? Again, the main thing to remember about the CCS is conductivity. If you could successfully measure your wash bath using conductivity, then the conductivity control system, or CCS, is for you. Unfortunately, the CCS doesn't do well in electronics applications. Last question is, will the KYZEN CCS make water additions to bring my concentration down? And the answer is the KYZEN CCS cannot make water additions. It does do a good job at a slow, controlled approach to your set point value. It doesn't just shoot up to it. But yeah, I hope the short presentation helps let you know what KYZEN offers as far as how to measure and control your wash bath concentration with different KYZEN devices that we offer. That's all I have today, but feel free to reach out to me or others at KYZEN if you want more information. I appreciate your time, and I'll turn it back over to William.
Thanks, Wayne. Thank you guys for watching this Tech to Tech session. If you would like to discuss this topic further or have any questions that were not answered in the session, please contact your local KYZEN regional manager or send an email to tech@kyzen.com, and we will have someone follow up with you as soon as possible. And if you like this video, be sure to follow us on our social media platforms for more expert cleaning content.